Okay, we're in multivariable calculus. We're taking a look at multivariable integration, and we're discussing where the order of the integration matters. In this particular problem, it's set up as dy dx. And so our job then would be to integrate y first. But looking at this integrand, we can't find the antiderivative of e to the minus y squared. It's not like you can just say, oh, it's e to the minus y squared. No, it doesn't work that way. What we need for this to work, we need a y so we can do a u sub. And so that's not going to work for us. Let's take a look at what this region is. We need to get a drawing of the region. It's very important. And so this is telling us that y equals x and y equals 2. And so then it must be that those are the lower limit and the upper limit. Those are actual functions that dictate to us the inside lower limit and upper limit. When you're doing dy dx, what you're doing is slicing vertically and then moving it horizontally. And so I like to draw this line in, put the circles at the end of the line because they dictate to you what the upper limit and the lower limit are on the inside. And so we have the lower limit inside is y equals x. The upper limit inside is y equals 2. This thing then moves from x equals 0 to x equals 2. And so that's what they have us set up as. But we're realizing that we can't do it in this order. So it's our job then to reorder. Our job is to, instead of dy dx, switch the order and do it as dx dy. So same region, but now dx dy is a horizontal slice, then moved upward vertically. And so dx dy then would have the circles at the end on the left and the right, and the left will be your lower limit inside and the right will be your upper limit inside. So we now have to figure out what these are. And then this thing moves from a lower limit outside of 0 to a higher limit outside of 2. So we need the x equals versions of these guys. They will end up as the interior bounds. Well, this y-axis is x equals 0, and this line is x equal y. And so now these are our new inside limits. And we're ready to go. The integrand doesn't change, the order of integration does. We go from 0 to y on the inside, we go from 0 to 2 on the outside. It's not just as simple as just switching these, around. You have to actually draw out the region. Draw a second copy of it, and then change it up, and then figure out what the new bounds are. Now this is supposed to be helpful to us. Why was this beneficial? Why was this switch good for us? It's because we're integrating with respect to x first. And this interior integral with respect to x is of a function who is only of y. That function is constant with respect to x. It's the same as integrating 4. With respect to x, the integral is 4x. So integrating e to the minus y squared with respect to x is just x e to the minus y squared. Now we have these bounds of x equals 0 and x equals y. And so we replace x with y, then we replace x with 0, and replacing x with 0, of course, would 0 the whole thing out. Now notice how I continue to write the outside integration. Please do this. It's important in your write-up. We're working our way inside out, but don't just ignore the outside. Sometimes you might forget about it, and so I don't want you to write it up this way. And so now we have the integral of y e to the minus y squared. dy, it's Calc 1 integral, first semester integral, and it's our job to integrate this. And before, we couldn't integrate e to the minus y squared by itself, but now we have a y there and we can integrate it. We can integrate it because we can do a u sub. The derivative of the exponent is almost exactly the outside part, the y d to the y dy. Not exactly. If we let u be equal to minus y squared, the exponent, the derivative of that is minus 2y dy. Our job is to replace y dy, and so we'll solve for it by dividing by 2. So we'll have minus 1/2 du will take the place of y dy. So we're now looking at an integral who is just e to the u with a minus 1/2 on it. Now that integral is just e to the u with the minus 1/2 on it. And now we'll sub back in and replace the u back with minus y squared. So we have negative 1/2 e to the minus y squared is the antiderivative of y e to the minus y squared. All right, great. Our job now is to plug a 2 in and then plug a 0 in for y. So we'll have e to the minus 4 when we plug a 2 in, and we'll have e to the 0. Don't always assume 0 gives you 0. When we plug the 0 in, we get e to the 0, and that's a 1. And there's your final answer. And so if you're given an integral, you should check to see if you could actually integrate in the order that is given to you in. And when you can't, we need to switch the order up. And the best way to switch the order up is to draw a second drawing with the opposite order, draw in this bar with the circles at the end, and really analyze it correctly, take your time with it, and eventually you'll be able to get faster with it. But that's the process of switching the order of integration in a double integral.